This is GDT Mark III membrane tank used to store liquefied natural gas or LNG during transportation. And this is one of the biggest and most complicated natural resources projects in the world. The Yamal LNG, with a whopping cost of $27 billion to build, located in northwest Siberia, in Yamal-Ninets region, which stores 80% of Russia's gas reserves. The Yamal LNG is a true engineering marvel, but the real game changer that allowed this hefty price tag to be economically viable is not what you think. Oh, and you know how projects of this scale usually tend to go over budget and deadline. I guess this one is a double. Not what you think. As the world transitions away from oil and the office commute, natural gas is increasingly viewed as a transitory step, while it's still a fossil fuel, and burning it produces greenhouse gases. It is a cleaner alternative, because when burnt natural gas produces 45% less carbon dioxide than coal and 30% less than oil. Natural gas currently accounts for about a quarter of the world's energy needs, and that share is expected to increase in the future. The Yamal LNG plant is located in Siberia, Russia, in the northeast part of Yamal Peninsula. In the indigenous language, Yamal means end of the land, and it literally is. When the project started in 2012, there was no road or water access to Siberia, and everything had to be built from scratch. This included a seaport terminal, an international airport, the plant itself, and all the housing and amenities that were needed. The massive dredging operations to create a deep draft channel into the new port of Siberia was conducted by the Belgium firm DEME. The shipping channel is 970 feet wide, 970 feet wide and 50 feet deep. But before construction could begin, there was a major issue: the polar night. Not the polar night, which lasts about 4 months out of the year. But that still didn't help. See, you can't really build in the Arctic using conventional methods, and that's due to permafrost. In the northwest Siberia, temperatures could drop as low as -58 degrees Fahrenheit, which permanently freezes the ground as deep as 1,300 feet. But in the summer, the top layer, about 6.5 feet deep, which is called the active layer, would thaw and turn into mud to drive in Siberia. You need big wheels. Another issue with the mud is that it's unstable, meaning traditional foundation would not work. The solution was to build everything on piles for the LNG plant alone. 65,000 foundation piles were hammered, 32 to 65 feet into the icy surface. This effectively raises the plant above the ground, but aside from the cold, the heat was also an issue. While the plant operates, it would produce heat, which could melt the permafrost below. As a result, 28,000 thermosiphon systems had to be engaged to refreeze the primary foundation to 25 degrees Fahrenheit. The LNG plant itself covers 444 acres, which is equivalent to 250 soccer fields, 200 wells at the nearby Huge Note and Biesco gas field. Supply: the required gas to the plant. The plant consists of 4 trains. No, not that kind of train, the LNG trains, which are basically liquefaction and purification facilities. That's because for economical transportation of gas, it has to be liquefied by refrigeration to below 258 degrees Fahrenheit. That's the boiling point of methane at atmospheric pressure, but the refrigeration shrinks the gas volume by 600 times, allowing for economical transportation. Music: a typical train consists of a compression area, propane condenser area, and methane and ethane areas. Before gas can be liquefied, it needs to be purified, because impurities can block the cryogenic sections of the plant. Because of the extreme environment and polar nights, the plant couldn't really be built on the spot, so instead a modular approach was taken, with giant sections being manufactured in China and shipped to the location where everything was put together. Just like Legos. Additionally, multiple LNG storage tanks were built. The storage tanks are big enough for a boat, right? Maybe even some fishing. Music: the first LNG train was launched on December 8, 2017, which signified the beginning of commercial operations. The opening ceremony was attended by President Vladimir Putin. 2 more LNG trains were launched in the following year, which was actually 1 year earlier than planned, and you're not going to believe it, on budget. How often do you hear that? So by the end of 2018, the plant reached a full plant capacity of 16.5 million tons of LNG per year. But if ahead of schedule and